This folder here is just a folder I created for this presentation. And this is a JDK. This is the file that is archived, but this is the file we're going to encrypt. And this is just an empty folder where we will keep our key pair. So the first thing we do is that we click New Key Pair. And when we have done so, we go to our folder here, and then we go to this folder. It can be named anything. And then we have to specify a name for our key pair. So we can take presentation. Yeah, we can name it presentation. And then we click save. And then we have a generated key pair. So if we look at this folder, we can see that we have our private key here and our public key here. And these are printed, written out to the file to a serializable file. A file that so Java can parse the objects as it can parse the file as object directly. It end up just reading all the bytes directly. It does that too, but anyway, what we then have to do if we want to encrypt the file is that we need to set in this case our public key. So then we click here, and then we go to and here is our public key. And now the public key path is set, and that we're just gonna encrypt the file. We don't need our private key. So then we click encrypt, and then we go to our file again. And this is the file we're going to encrypt. So we click on open here. And then it starts to encrypt it. So there we go. And the files that you saw were generated here are temporary files while the encryption process is taking place. So it's supposed to be like that. And here is our encrypted file. And it should be noted that this file is actually an archive. So you can go into this file if we do like this and do like this. We can do this is not something you're supposed to do, but I just want to show you to prove the safety. So here is the actual files, because this is just an archive. But here are the files. So here is the actual encrypted file that is encrypted with the symmetric AES key that we encrypted with our public key. And this is the symmetric key, but it is in an encrypted format. So you can't just take this key and decrypt this file because you need to use the private key that we generated in order to decrypt this secret key. And this file is the initialization vector. So we have a different EV every time. It increases the security. We can remove, you don't need to um, extract the archive. This was just to show that this is not unencrypted files. It's supposed to be like this. Still safe. So if we delete this, because this is the file that we use when we decrypt it from this application. In order to decrypt this file, we need to add our private key to the path. And when I say to the path, I mean there is properties file or a config file where those paths are set. So you can manually edit that file if you want. And that is also something that I recommend, that if you have those paths in a config file, then everyone who has access to that file can see where you keep your keys, so you can always clear that file. I can show that later. But now we can set the private key, and then we go here, and then we go to our key pair, and then we choose private key here and open. So now we have that set to, and now we can click decrypt. And if we go to here and here, then we choose this encrypted file, or this archive with encrypted files, to be totally precise. What we also can do before is that we remove this file that we encrypted, because I chose to not remove the original file. Maybe some people want that, some people don't want that, but I all think that is a better solution to keep the original file, and then you can manually delete it, because uh, it's not really deleted like anyway. Um, and then we're gonna remove this, and then we click here and open, and then it will start to decrypt it, given that we have set the private key path. So we do like this, and then it starts the decryption process. And now it's finished. And I can tell you also that just because you see this file here at first doesn't mean it's decrypted, because when you encrypt or decrypt large files, you can't keep the whole um, all bytes of the file in the memory. What you have to do is that you have to, unless you have a very big memory, of course, but what you have to do is that you have to buffer uh, some of the file you want to either encrypt or decrypt uh, uh, to your primary storage. That is your disk, your hard drive. Uh, so a non-volatile storage compared to when you keep it in memory, where it's volatile. But that is also a good thing, because say that I want to test multiply keys, if I had malicious intent, uh, then um, then I would probably have some application that had a lot of keys and like tested if they worked. But the thing is, when you have this solution that is in FileEncryptGUI, if you provide um, a key that is not correct, the first thing that will happen when you click on decrypt is that the application will start buffer the the whole part of the file to the hard drive, and that is it takes some extra time, but that is actually good, because you can't like try 5 keys in like milliseconds, because it takes time to like physical, maybe the wrong word, but to actually or practically write like a 1 gig file to the disk. This is not a 1 gig file, but just for the example, uh, if you just use memory for encryption, there is two problems with that. The first problem is that if you want to encrypt a file that is like say 20 gigs, you would need a very big memory. And then if you take like 100 gigs, you would also need very much memory. The other con with using with only encrypting from and keep the file in the memory is that uh, uh, it will be very easy to make like brute force attack. Say that you have a lot of combinations you want to try out, or you have some like private asymmetric key malicious applications, like trying to crack um, public or private keys and such. Now that is really hard, but uh, you should always like prepare for all the different cases, and keeping the keeper in a sterilizable form and in files. I think it's some benefits with that actually. But then, of course, when quantum computing and really comes to the public and to states that is too, then with RSA and AIS will be a problem, no matter how you build it, because you can always like go to the encrypted file and skip these applications, and then you could try all your hacking applications if you like want. So uh, this is actually the thing I wanted to show you. The last thing I wanted to say about this application, because I made this application a few years ago, I think, but I still use it because it's good and it works. But one benefit I find is that you can actually only set the public key path. And when you do that, if you encrypt a file, you can have the private key path that is um, not path, but private key file. If you keep this like on a external storage, then you can encrypt files all you want. You couldn't decrypt them yourself. Of course, bad people could use this like with malicious intent also, but it could be used for good as well, because it's kind of safe to like uh, know that even if my computer got hacked, I can't decrypt it, so the hacker can't decrypt that file either, and that is good. I'm sorry, I need to mention one more thing about this application. Um, this application is also very good for education, because in order to use this, you have to set the public key and set the private key path. And if you have failed on any of those steps, it won't work either to encrypt or decrypt. So if you sit with this application for a while, you will learn the concept with asymmetric um, encryption or asymmetric cryptography, I should say. Of course, when you crypt large files, you can't just use RSA and private public. So the actual encrypted file is encrypted with AES. But that's the standard way to do it, and it has worked uh, for a long time. So I'm really impressed about the guys who made this algorithm, RSA, then, because it hasn't like been broken until quantum computers. And I'm impressed by Peter Shor's also. And probably we have reached 1 million qubits. I think so, at least, but it's a war, so we will never know. Um, but that is also a subject uh, that the IT industry needs to think about, because I think in just a couple of years, or maybe we are already here. state will have access to quantum computers with 1 million qubits or more. And there are state hackers. We should not be naive about that part. And that's why, like, the top IT organizations need to prepare for quantum computing attacks and have a plan um, how to adapt the encryption algorithm, because you can't always uh, uh, use what worked yesterday. And one good strategy, because I read some articles about this, and one good strategy, I think it was Iron Core Labs that recommended this step, is that if you work as a developer, that if you build a method, or a system, a code block that encrypts something or decrypts something, then that you have that you build it like an interface so on top of it, so you have if RSA or OIS or something suddenly is not sufficient, then it would only be a question of what encryption algorithm to put there, but it would not be a question about refactor all the code. So that should almost, according to me, be like a requirement for how to write encryption code in the top organization. And the last thing, now talked a lot there, but I will show you the config file as well. Because I promised you that. There is a Java 8 version of this as well, and it works fine just running the Java 8 project from a jar, and this as well. But then you need to have the core JRE to with Java FX, and most of the JREs and the core doesn't provide that by default. So I think this Java 11 project is with Maven is the best way to run it. So if we look at this here, and then we go, and then we have a keystone properties. If you use the jar version, you can just you will only have the jar file, and then you will still have keeping properties, but not all the Maven stuff. But if we go, if we type out this file, you see that here are the paths, and you can basically do, because you can reach these files uh, from this file handler GUI version also. You can just open it, and you can just remove like this part and this part. But if you remove this part, you need to set the encryption keys again. But it can be good, especially if you have the key store on external storage, then you might not want to have this information available in the keeping properties file. Um, so that is it. I meant to say. I hope someone um, had use of this video. Um, and if anyone has any questions to this, you can mail me at snow_900@outlook.com, or you can reach out on LinkedIn or something. Cool. Bye.